Hello, my name is Greg Cassidy, and I am DHEC's project manager for the former Joslyn Clark Controls Facility. This is a presentation going over the proposed plan for the site. Our agenda is to look at what a proposed plan is and the purpose it serves, go through a brief history of site activities to date, discuss potential cleanup alternatives, share what DHEC's preferred cleanup alternative for the site is, and provide an opportunity for you to share comments and questions with DHEC on the proposed plan. DHEC has completed an evaluation of cleanup alternatives to address contamination. The proposed plan identifies DHEC's preferred alternative for cleaning up the site and the reasoning for this preference. The proposed plan includes summaries of the other cleanup alternatives evaluated. If you would like to review an electronic copy of the proposed plan, it is available to download from www.scdhec.gov/JOSLYN-CLARKCONTROLS. I will show this link again at the end of the presentation. The purpose of the proposed plan is to inform the public of DHEC's activities, gain public input, and fulfill the requirements of the Comprehensive Environmental Response, Compensation, and Liability Act and the National Oil and Hazardous Substances Pollution Contingency Plan. The public comment period will run from September 1st until October 15th to accept your comments. DHEC will select the final cleanup remedy after reviewing and considering the comments received. DHEC may modify the preferred alternative or select another response action based on new information that may become available or from public comments made during the public comment period. The public is encouraged to review the proposed plan and any of the available decision documents available on DHEC's website and comment on all of the alternatives presented. The former Joslyn Clark facility is located at 2013 West Meeting Street in Lancaster, South Carolina. It is identified on this figure with the red box. The site is approximately 3 miles west of downtown Lancaster. This is an aerial view of the site. The property consists of 23 acres of land and is developed with 2 buildings. A 180,000 square foot manufacturing building constructed in 1964 is the main structure at the site. A railroad spur is located in the southwest corner, which is connected to a rail line that runs along the southern property boundary. The property was used to manufacture electrical control equipment for fire safety purposes from 1964 until 2009 when operations ceased. The property was vacant from 2009 until 2016 when it was purchased by Macrochem. The site is currently used to transfer carbon black from bulk quantities to smaller quantities for warehousing and subsequent distribution to off-site locations. Soil investigation activities took place between 2009 and 2011. 18 borings were advanced to evaluate 8 potential source areas. Trichloroethylene, or what we refer to as TCE, was identified in site soils near the former metal plating area, the former degreasing operation, and the former hazardous waste storage shed. Groundwater is affected by volatile organic compound contamination, or what we often refer to as VOC contamination. VOC-affected groundwater originates in the northwest portion of the manufacturing building and extends southward towards the southern property boundary. The source of this contamination is likely the former paint booth and sump area located in the southwestern portion of the building. Trichloroethylene, or TCE, is the primary VOC contaminant in groundwater. This figure depicts the extent of TCE in the shallow groundwater. The darker colors indicate higher concentrations of TCE in the groundwater. The highest concentrations of TCE are in the former paint booth and sump area within the footprint of the manufacturing building. The plume extends to the southern property line. This figure depicts the extent of TCE in the deeper groundwater in the fractured bedrock aquifer. The extent of TCE in the fractured bedrock extends approximately 400 feet south of the property boundary and onto an undeveloped parcel. Soil vapor has been assessed in the former manufacturing building through a passive soil gas survey conducted in 2012. A subslab and indoor air sampling event in 2014, and then a follow-up subslab sampling event in 2015. The passive soil gas investigation included 60 soil gas points that were installed in the northwest portion of the manufacturing building. Vapor intrusion was evaluated in the building by the collection of 6 subslab soil gas samples along with 6 co-located indoor air samples. Indoor air concentrations of TCE were below the screening level for the industrial air, which indicates that vapor intrusion is not a risk for workers at the site. Human health and risk assessments have been prepared in 2013 and 2020 to evaluate potential health impacts for current and future site workers. The primary risk is exposure of humans to affected groundwater. Groundwater is not used, and this risk will be administratively mitigated through the use of an institutional control prohibiting the use of groundwater at the site. Additionally, due to the depth to groundwater, the potential for human contact with groundwater is unlikely. We refer to our site cleanup goals as remedial action objectives. They are developed in order to set goals for protecting human health and the environment. Our remedial action objectives for the site are to remediate groundwater to prevent the human ingestion of contaminated groundwater, reduce the contaminant concentrations below federal and state maximum contaminant levels, and to monitor the groundwater quality until it is restored to drinking water standards. Based on information collected during site investigations, a focused feasibility study was conducted to identify, develop, and evaluate cleanup options and remedial alternatives. The cleanup alternatives that have been evaluated as potential remedial alternatives are no action, monitored natural attenuation or M&A, zero valent iron or ZVI, hydraulic containment, in situ chemical oxidation or ISCO, and anaerobic bioremediation. In the following slides, I will tell you a little bit about each of the alternatives and the cost to implement the remedy. No action is included as a baseline for comparison with other alternatives. This is a requirement by the National Contingency Plan. Under this alternative, no action is taken to treat or prevent potential exposure to contaminated groundwater or reduce the volume, toxicity, or mobility of site contaminants. This action does not include any institutional controls or groundwater monitoring. This alternative would not be protective of human health or the environment and could take more than 100 years to achieve the cleanup goals. M&A is a passive approach that monitors the natural degradation or reductions of contamination in groundwater. A typical M&A approach centers on monitoring groundwater regularly to evaluate and confirm that site conditions are supportive of contaminant degradation. Long-term groundwater monitoring would be expected to be needed for approximately 50 years, and institutional controls to restrict development and groundwater use would be implemented. The cost of M&A is expected to be approximately $500,000. Zero-valent iron, or ZVI, involves the introduction of iron particles to act as a reducing agent to chemically reduce contaminants. The process involves a contact reaction between the iron surface and the TCE in groundwater. ZVI can be delivered to the subsurface either through soil blending or pressurized injection. Institutional controls and long-term groundwater monitoring would be included in this remedy. The cost of this remedy is approximately $6.3 million. Hydraulic containment involves extracting groundwater from the aquifer, treating it, and then discharging the treated water. Institutional controls and long-term monitoring would be included in this remedy. The cost of this remedy is approximately $2.2 million. In situ chemical oxidation, or ISCO, reduces the mass of contaminants by injecting an oxidizing agent into the subsurface. The oxidizing agent is usually injected into the aquifer via a direct push rig or through a permanent well. Sodium permanganate is likely to be used as the oxidant. An on-site ISCO pilot test was conducted in the former metal plating area and successfully demonstrated that ISCO can be implemented under site-specific conditions. A reduction of over 90% of the contaminant mass was achieved with very limited rebound over a 5-year period. Institutional controls and long-term groundwater monitoring would be included in this remedy. The cost of this remedy is approximately $1.1 million. Anaerobic bioremediation is a process that uses bacteria to biologically transform contaminants into non-chlorinated organic compounds. Carbon substrate is delivered to the subsurface through permanent injection wells or by direct push points. Institutional controls and long-term groundwater monitoring would be included with this remedy. The cost of this alternative would be $1.7 million. The National Contingency Plan requires that DHEC use specific criteria to evaluate and compare the different remediation alternatives in order to select a remedy. The evaluation criteria we begin with is the overall protection of human health and the environment. When evaluating alternatives in terms of overall protection of human health and the environment, consideration is given to the manner in which site-related risks are eliminated, reduced, or controlled through treatment, engineering controls, or institutional controls. The second criterion is compliance with state and federal regulations. This evaluates whether an alternative meets federal and state environmental statutes and regulations that pertain to the site. The third criterion is long-term effectiveness and permanence. This looks at how effective the alternative is at reducing the risk at the site and the reliability for the remedy to maintain a reduced risk over time. The fourth criterion is the reduction of toxicity, mobility, and volume through treatment. This is the degree to which an alternative employs treatment to reduce the harmful effects of contaminants, how the alternative limits the ability for contaminants to move in the environment, and also how the alternative reduces the amount of contamination present. The fifth criterion is short-term effectiveness. This looks at any risk the alternative poses to on-site workers, the surrounding community, or the environment during implementation, as well as the length of time needed to implement the alternative. The sixth criterion is implementability. This considers the technical and administrative feasibility of remedy implementation, as well as the availability of required materials and services to complete the alternative. Cost is the seventh criterion. This is the estimated active remediation cost and does not include the cost of ongoing groundwater monitoring. The final evaluation criteria we evaluate is community acceptance of the preferred remedy. This is evaluated after the public comment period has ended. Based on community acceptance, DHEC may modify the preferred alternative or select another remedy. After comparing each remedial alternative with each other using the evaluation criteria, each alternative was ranked with a scoring system to look at how well it performed in each criteria. The scoring system gave each alternative a ranking from very favorable with a score of 10 to very poor at a score of 1. As you can see from the scoring system, alternatives 1 and 2 score very well in implementability compared to the other alternatives because they are both passive treatment options and require no construction to implement. They each scored poorly when it came to the first 4 criteria and providing effective remediation at the site. The 4 active remedial alternatives, alternatives 3, 4, 5, and 6, score similarly throughout most of the evaluation criteria. In situ chemical oxidation is slightly better than or equal to the other active remedial alternatives when compared directly. Cost is evaluated with all of the remedial alternatives, but more emphasis is placed on how well the alternative will perform in the first 6 evaluation criteria. Cost will become a larger factor in the decision-making process if 2 or more alternatives ranked very close to each other but had significant cost differences. DHEC has identified alternative 5, in situ chemical oxidation, as the preferred remedy for the site. The alternative would involve the injection of sodium permanganate solution into the aquifer via a direct push rig or using permanent injection wells. The oxidant solution will react with any organic compounds encountered and destroy or chemically transform the contaminants to a higher valent state. Typically, contaminants are converted to carbon dioxide and water. It is expected that there will be 5 injection events conducted over a 5 to 6 year period. An on-site pilot test was conducted with ISCO that successfully demonstrated that it can be implemented under site-specific conditions. A reduction of 90% of the contaminant mass was achieved with very limited rebound over a 5-year period. The alternative will substantially reduce contaminant concentrations in the source area. Long-term groundwater monitoring would be required and institutional controls would be established to restrict the use of groundwater. It is expected that it will take greater than 10 years for contaminants in groundwater to be below EPA maximum contaminant levels. This alternative is the best solution in terms of the overall protection of human health and the environment, long-term effectiveness and permanence, reduction of toxicity, mobility, or volume through treatment, and has the shortest active remediation implementation period. The alternative also mitigates further groundwater impact. The estimated cost for implementation for this alternative is $1.1 million. So, what are the next steps for the site? DHEC will take any comments or questions on the proposed plan until October 15th. After DHEC reviews any received public comments, DHEC will identify the selected remedy in a record of decision. Following the record of decision, the responsible party, Joslyn Clark, will develop a plan to construct and implement the selected remedy and submit it to DHEC. DHEC's administrative record is available at DHEC's webpage for the site. Along with the proposed plan, all of the reports that were utilized in developing the proposed plan are available there. DHEC encourages the public to review these documents to gain an understanding of the site and the activities that have been completed. Additionally, the administrative record is available through DHEC's Freedom of Information Office at 2600 Bull Street in Columbia. Their phone number is 803-898-3817. DHEC is accepting public comments on the proposed plan from now until October 15th. Comments can be made in writing or by email to Greg Cassidy at 2600 Bull Street, Columbia, South Carolina 29201, or at casidga@dhec.sc.gov. If you have any questions about the site or the proposed plan, please contact me by email or at 803-898-0910. Once again, the public comment period will be open through October 15th. Thank you for your time, and thank you for watching this presentation.